Hello everyone, welcome to the course Digital Signal Processing. I am Ravi Gatti, Assistant Professor, Department of Electronics and Communication Engineering, Sri Venkateswara College of Engineering, Bengaluru. I welcome you all for the course Digital Signal Processing, and the subject code is 18EC52. In this digital signal processing, so in order to say that what exactly you're going to study in this course it is a continuation of what you have studied in signals and system. So you can see here the prerequisite in order to understand this digital signal processing is you must know the knowledge of signals and system. So if you know the signals and system very well means then we can easily grasp some of the concepts what we are going to use in the digital signal processing. So basically this digital signal processing, what we are going to do is we are going to process the signal. Why? Because most of the data transmission nowadays, whatever it is happening in the digital manner only because of the advancement in the VLSI technology. So whatever the processing operations it has to be done in a digital manner. So therefore, whatever the information we have, it has to be transmitted or it has to be processed. It has to be done in a digital manner. So therefore, we need some tools or we need some techniques so that we can process the given signal as quickly as possible and we can arrive at the desired result. So in order to arrive at the desired result, we go for this digital signal processing. In this subject, you're going to learn about some of the fundamental techniques, how you're going to process the signal. It may be in terms of filtering mechanism, or it may be in terms of implementation voice, or it may be in terms of a realization subject or realization concepts. So in this digital signal processing, one of the fundamental transformation what you're going to use, that we call it as a discrete Fourier transformation. And I hope everyone we already know some of the transformations what we have studied in signals and system. So we studied about a Z transformation, we studied about a linear Laplace transformation, we studied about a Fourier series and Fourier transformation. See, whatever the concepts we have studied in Fourier series and Fourier series, the next advanced version of those transformation, we call it as a DFT, that is a discrete Fourier transformation. So basically in this digital signal processing, we are going to study about discrete Fourier transformation. And we all know that we are going to use a Fourier series for transformation in frequency domain for a periodic signal, whereas for the non-periodic signal, we are going to use a Fourier transformation. So the advanced version of the Fourier transformation, we are going to call it as a discrete Fourier transformation. So the overall details and how we arrive at the expression and what are the processing techniques we are going to use through the use of DFT, all those details we are going to study in this subject that is called as a digital signal processing. Now let us look into the syllabus. So this is the syllabus what you're going to study in this course. In the module number 1, so as I said, we are studying the advanced version of the Fourier transformation, and that transformation we call it as a discrete Fourier transformation. How we are going to arrive the expression for discrete Fourier transformation? So for that we have one derivation. So we will be using that derivation. So through the use of that derivation, we can arrive at the expression for discrete Fourier transformation. So once we have the expression for discrete Fourier transformation, then we use some examples in order to solve the problems, and we will be using some properties of this discrete Fourier transformation in order to solve the various problems. So for that we will be using some of the properties like linearity property, symmetric property, multiplication of two DFTs in time domain, and multiplication of two DFTs in frequency domain. So all those properties you're going to learn in the module number 1. So once we are aware about the expression for that is a discrete Fourier transformation, now in the second module we go for applications of the discrete Fourier transformation, where and all we can make use of the discrete Fourier transformation. So in one of the field what we can use this discrete Fourier transformation is called as a linear filtering mechanism. Means if you have a long data sequences, if you want to find out the convolution of the long data sequences, means it will be a tedious process. If we use this discrete Fourier transforms, then we can able to calculate the long data sequences. That is, it may be a linear convolution or it may be a circular convolution, can be done as fast as possible through the use of this discrete Fourier transformation. And when we use this filtering mechanism, two important methods you're going to learn in this module number 2, and those methods we call it as a overlap add method and overlap save method. So those are the two important methods what you're going to study in the filtering mechanism. And after arriving on solving a lot of problems on discrete Fourier transformation, the next process is how optimize the given process, or how I can optimize the given problem so that I can arrive the result as quickly as possible. So there are some drawbacks were there in calculation of the discrete Fourier transformation in a conventional manner. Now we want to optimize the calculation of discrete Fourier transformation. So therefore we go for one more type of transformation or one more type of DFT algorithm, and those algorithms we call it as a fast Fourier transformation. Through the use of this fast Fourier transformation, we can calculate the discrete Fourier transformation of the given signal as quickly as possible. And this FFT algorithms, it is also called as a radix 2 algorithm. Why? Because in a 2 to the power of n, in that samples only we can able to calculate the DFTs of the given signal. Therefore, FFT algorithms are also called as a fast Fourier algorithm, or it is also called as a radix 2 algorithm. So there are two types of transformations you are going to study in fast Fourier transformation. One we call it as a decimation in time, and one more is called as a decimation in frequency method. So through the use of these two methods, we can able to implement a radix 2 algorithm. So all those details you're going to learn in the module number 3. Now, in the module number 2, sorry. In the module number 3, what you're going to study is the design of digital filters. Generally, we are going to study two important digital filters in the digital signal processing, and that we call it as a IIR filter and FIR filter. What do you mean by IIR filter is infinite impulse response filter, and FIR is finite impulse response. So I'm going to study about the design aspects and the implementation. What are the methodology we are going to learn in the design of FIR filter? All those details you're going to study in the module number 3. In implementation of the FIR filter, one of the important techniques you're going to study, and that technique we call it as a windowing technique. So in the windowing technique, there are different window functions are there. For example, rectangular window you have, Hamming window you have, Anning window you have. So with the use of these techniques, we can able to implement the FIR filter as efficient as possible. In the module number 4, you're going to study about one more implementation that we call it as a IIR filter, that is an infinite impulse response filter we are going to study about. We are going to make use of the bilinear transformation method, and we are going to use a transformation from low pass to high pass. Or if you want to do the design of any filter, let's say you want to design a high pass filter, if you want to design a low pass filter, if you want to design a band pass filter, it can be done through the use of a fundamental low pass filter. So for there, we are going to use some transforming techniques we are going to use. So all those techniques you are going to study in the module number 4. And finally, in the module number 5, you are going to study about the core. What are the digital signal processors are there? How these processors will implement a basic operations like arithmetic addition, multiplication, subtraction, and logical operations. How practically it will be implemented, we'll be studying in the module number 5. Along with that, you're going to learn about the floating point representation. So you're going to represent a floating number in different forms. One we call it as a IEEE floating point format, or one more we call it as a fixed floating point representation. So all those details you'll be learning in the module number 5. So this is the syllabus what you're going to study in this digital signal processing. Now the textbook for this syllabus is, so we are going to use a digital signal processing by using ProAkis, and ProAkis we are going to use. And for the references, we are going to use these three textbooks that we use from the OpenAM, and one more is from by SK Mitra, and one more is we are going to use a LeetApp. So if you want to solve more problem means, then I request everyone you go for a Ganesh Rao textbook. So with the use of Ganesh Rao textbook, there are n number of problems are there for you people to practice. So along with this prescribed textbook, I request all the students you should have a Ganesh Rao, that is a local author, so that you can solve more problems. So you can well verse with the concepts what you are going to study in the theory part. And this subject, you can do several number of projects through the use of this digital signal processing. Why? Because this digital signal processing, whatever the applications you want to implement, we can implement through the use of the MATLAB. So that is nothing but a matrix laboratory. So in this semester you have a one more laboratory called as a matrix laboratory. So with the use of this matrix laboratory, whatever the operations or whatever the concepts you are going to study in the digital signal processing, it is possible for you to implement in real-time simulators or in real-time scenario through the use of this software, MATLAB. And this MATLAB in today's also, most of the academician and researchers, they are going to use this MATLAB for their research activity. So it is a best opportunity for all your students. So whatever the concepts you have, you represent it in the formula or you represent it in the form of problem, and that can be solved through the use of the MATLAB. So this is the one of the best opportunity for the students, where you are learning both the theory and practical in a single semester. So I request all the students, if you have any problem means, you make it in a format that can be implemented, or you represent it in a such a way that it can be easily understandable, and so that it can be implemented in a practical manner through the use of this MATLAB. So these are the concepts what you're going to study in this subject. So the remaining